Hello everyone, I, Yashi, along with my teammates Rishabh, Aditya, Hemangi and Amay are doing a project on detection of cross-site scripting attacks under the guidance of Dr. M. Rajasekhara Babu from the School of Computer Science and Engineering. In this video, we'll discuss about introduction, about what cross-site scripting attacks are, related work, gaps in literature surveys, problem statement and objectives, design and experimental demo, result analysis, conclusions, future enhancements, and references. Now, talking about the terms that are used in XSS, cross-site scripting. Cross-site scripting is a code injection attack in which an adversary inserts malicious code within a legitimate website. Vulnerability. Vulnerability refers to any weakness in an information system, system processes, or internal controls of an organization. Malicious code. Malicious code is harmful computer programming scripts designed to create or exploit system vulnerabilities. Now, if we talk about cross-site scripting attacks, cross-site scripting attack has been an unremitting problem for web applications since the early 2000s. It is a vulnerability in a web application that allows a third party to execute a script in the user's browser on behalf of the web application. It allows an attacker to circumvent the same origin policy, which is designed to segregate different websites from each other. Different types of cross-site scripting attacks. There are three types of XSS attacks. The first one is reflected XSS. In reflected cross-site scripting attacks, input has to be provided each time to execute. It is mostly carried out by delivering a payload directly to the victim. Stored XSS. In stored cross-site scripting attacks, the response containing the payload is stored on the server in such a way that the script gets executed on every visit without submission of payload. And the third type is DOM-based XSS. Its instances are either reflected or stored. It arises when user-supplied data is provided to the DOM objects without proper sanitizing. Now, the question arises that why do we need to protect ourselves from cross-site scripting attacks? The answer to this is that with the increased use of internet, web applications and websites are becoming more and more common, due to which cyber attacks on web applications and websites are also increasing. Of all the different types of cyber attacks on web applications and websites, cross-site scripting attacks are one of the most common forms of attack. An attacker who exploits a cross-site scripting vulnerability is typically able to read any data that the user is able to access and capture the user's login credentials, impersonate or masquerade as the victim user. Cross-site scripting attacks enable attackers to inject client-side scripts into web pages viewed by other users. The attacks on the users by exploiting the vulnerabilities of the browsers have increased at an alarming rate. The existing attack detection strategies have failed miserably in most of the situations. Moreover, users have also not taken much care of configuring the browsers securely using available extensions and plugins. The scripts are also executed automatically without the user's permission unless he disables it. The users therefore need to protect themselves from these vulnerabilities, hence the detection of cross-site scripting attacks is very important.
The first research paper we refer to is GAG's effective payload generation method to detect XSS vulnerabilities based on genetic algorithm. The authors have proposed a novel genetic algorithm-based fuzzing scheme to address the problems of cross-site scripting attacks, in which at first a small number of initial attack vectors are generated in view of the interactive environment of the web application, and then the attack vectors are sequenced into genes, which are then used to detect the attack. Here are some demerits of this approach, such as too much randomness, which consumes a large amount of time and more. Now coming to the deep XSS cross-site scripting detection based on deep learning, the approach uses a decoder to restore original data from the obfuscated data, which is a key part of the process of pre-processing. Secondly, it uses word2vec to extract the semantic information to XSS attacks, payloads, and maps them to feature vectors. Demerits are the number of datasets used to train were not enough and can be added more to improvise the model. Let's see the third research paper, which uses a new approach to analyze the different web vulnerabilities through their WVF tool. This approach takes web URL as an input to detect web vulnerabilities. The demerits are that the check must be non-invasive, but in this case, some of them may be invasive due to some vulnerabilities. The fourth research paper takes the approach of selection and implementation of DOM-based features for XSS detection using OWASP web application and applies fuzzy logic inference system to web application vulnerabilities detection. Demerits in this are many important categories of vulnerabilities are triggered by unexpected user inputs and can appear anywhere within the application. This is the fifth research paper, and the approach is a new approach that integrates evidence from both a web request and its response in order to better characterize XSS attacks and separate them from normal web transactions. In this approach, complete payloads of XSS and normal web transactions from two databases are collected and features are extracted from them using the word-to-vec technique. Demerits are that in some studies that use malicious scripts from the XSS project and very different benign scripts from DMOS or ClueWeb09, some of the results were too good to be convincing. Testing out the approach on more realistic traffic may yield in more useful findings. Now we see the summary of all the 5 research articles that show the author and the year of the articles, implementation of the articles, or the model used, demerits of the models used, and the future scope that how can the model be further increased with better enhancements. Thank you.
I'm going to explain about the main objectives and the problem statement of our project. Due to the rapid advancement of the internet and the people's heavy dependency on the internet and the increasing services of the web applications, making the network applications technology has become more sensitive to cyber attack. To effectively detect and defend XSS attack are still one of the most important security issues. Extension helps us to detect whether a website is vulnerable to XSS attack or not. Talking about the objectives, to explore the various vulnerabilities caused by XSS, to study various types of cross-site scripting attack, to explore why we need to protect ourselves against XSS attacks, to design a procedure that estimates if a website is vulnerable to XSS attack or not. Here is the design of how XSS attack takes place. First, attacker used to inject the code into the target website, and when the user accesses the targeted website, from that website, the malicious code transferred to the user browser, and hence the attacker gains control over user's data or system via injected exploit. This design gives the overview on what level can malicious code through XSS attack control the system. It controls the application. It accesses the admin applications, edit user server security levels, server access sensitive data, and local network accesses. Now understand the process of XSS detection through this block diagram. First, the extension captures the URL of the current open tab. The URL is passed through the scanner Python file. A dummy JavaScript is created to inject it into the website. The forms are transferred through. The details of the form, action, method, and input are extracted. The JavaScript is inserted into the text input field, and from that is submitted using all the details. If the script gets inserted to the website, then it is vulnerable. Otherwise, it is not vulnerable. Let's see the design of a JavaScript injection. JavaScript injection is a process by which we can insert and use our own JavaScript code in a page, either by entering the code into the address bar or by finding an XSS vulnerability in a website. Note that the changes can only be seen by you, not are permanent. Let's see how the algorithm. Let's see the algorithm on which our project is based on. First, the user or victim will first log into his account. User must download the extension on his or her web browser. User must open any web page. The URL of the current open tab will be captured by the extension. The extension send it to our created backend. It extracts the URL in the backend and pass it to the scanner Python file. The beautiful SOAP library in the Python code detects the form on the web page. A dummy JavaScript is created to inject into the web page. All the forms present on the web page are reversed thoroughly. The details of the form, like their actions, methods, and inputs, are extracted. The form is then submitted using all the details we got. Insert JavaScript in the text input field. If the script gets inserted to the web page, then it is vulnerable. Otherwise, it is not vulnerable. Let's see the system flowchart. First, we start by using victim login, his Blogger account. Then it's submit the user ID and password to the website. Victim browsers and the malicious JavaScript posted by the attacker. If JavaScript interpreter invoked, if this happened, then malicious JavaScript get executed in the URL of the victim browser. If not, then web server of the victim will respond with error. Cookies will get write the URL of the victim's web browser, and it stops the process. There are some hardware and software required for our project. Laptops with an OS, Windows, Mac, Ubuntu, process of 1.8 GHz, Intel Core 1 i3 or higher version, memory RAM of 4 GB or more, and softwares like Python, VS Code, and Node.js are the requirements for our project. Thank you.
Greetings, sir. Myself Aditya Gupta, and I will be showing you the demonstration for the extension that we created. But before going to that, first of all, I would like you to show a demo for a XSS type of attack. So this is a dummy website that has been specifically created for testing out this XSS vulnerability only. So what we can do in this website is that this is a form. So what does this form do? If we type a query and do the search, it takes that thing into the URL and then it extracts those parameters from that URL and searches them. So basically, this website is XSS vulnerable. So if we put this script code, this JavaScript code in this input text field, and we press the search button, so you can see this code gets inserted over here, and then here we can see this alert has been displayed. So this basically shows that this website is XSS vulnerable, and here we only put this alert thing, but here an attacker might also put some other code that can help him to get secret credentials or access to database. So it will be very harmful for our database. So now, but if we try the same thing on any of our trusted website like GitHub. So here in GitHub also there are actually two forms, one this email address form and the other over here search form. If we run the same script tag over here also, here it does not happen. The alert does not show over here because the website is not accessible vulnerable. So yeah, so like how will how will our website or how will our like extension help in detecting whether a website is vulnerable or not? So now going to the code. So this is basically, this folder contains all of our source code. So so we have first created an extension. The extension uses this manifest.json file. Here we gave the name of our extension, the version of our extension, and here on the default pop-up that is basically on touching the icon of our extension, what will be shown. This is this HTML file we have linked with it, and these are the permissions that we are getting. So we want the permission of what is the active tab and all the other tabs permission. This is the popup.html file. Basically, this is the file that will be displayed when a user clicks on the extension, and over here only we will display the user whatever the result of our vulnerability test is. So here I have attached the JavaScript file and also the jQuery library we are using. So in the index.js file, we are using this Chrome global variable. So with the help of this, we will be able to get the current tab. Like this will be the tab which is currently active. So we get the URL. We get the URL of the current tab, and what we will do with that URL is that, so we have created a backend, and on that backend we have created a route. and we will that route, basically the duty of that route is that it gets this URL that we will be sending here in this from this get request. Along with that, we will attach this this URL that we will be getting. We will attach this URL like over here. You can see that I attached with this parameter. I attached this URL, and this is the currently our server is running on, will be running on the local host. So this is the URL from where our extension is going to fetch the result. And in the parameters, I have added this current tab URL. So what will this do is that we will fetch this URL, and then the and from this our server will give us a result, and then we will display. Well, so false or true is that basically it shows that if it's false, it means that website is not accessible vulnerable, and if it's true, then it is, and then we will display this message accordingly. So now coming to our server.js file, which is basically the file that will be, this is the server file. It's running on the local host. So I have used the Express library over here to create this server, and also this spawn library, which helps us to create a child process. So over here, we have first enabled the cross control origin. This we have given the permission. So what it does is that like it allows a get request from any domain to like our server. So like from whatever website we are trying to access this server, it will allow that. So now this here, as I told that this is the route that we created. In this route, we get a request, and that request is the link, or you can say that current tab URL. So we use that request tab, and then here we spawn a child process. In that child process, we spawn this XSS scanner, a Python file. This Python file will be the main file that will be doing the vulnerability check. I will be showing this file in a minute. Then what we are trying to do over here is that whatever the output is generated by this Python file, we are actually storing it in a variable called data, and then we will convert that data to string, and then we will feed it to another variable data to send, because then we will use this data to send variable to send this response back to the client. So here we have created some event listeners, and here we can see that our app, or you can see the server, will be running on the port 3000. This is the main XSS scanner file. So what here we have imported some libraries that will be used for our working. So here the code execution will start from this thing, URL system.argv1. So here you can see that server.js file. Here we have passed this URL over here, which we got from the request, and here this we will get this URL, and so with this URL we will be running this function called scan XSS. So in the scan XSS, function, we pass the URL that we have to check for detecting the vulnerabilities. So in this function scan XSS, what we do is that first we try to get all the forms that are present on this website. So we run this function get all forms, and we provide it with that URL only. So here get all forms, here with the help of this beautiful SOAP library, we try to get all and this HTML parser, we try to get all the forms that are present on the website. And then once we have got all the forms, so then we print this, how many forms we detected, and then we create this dummy JavaScript code that we will try to inject. Now we also declared a function over here, a variable over here is vulnerable, which is currently false, and it will return true if this code gets inserted in it. Now we will traverse through each and every form. First of all, what we will do is that we will get the details for every form. So we will run this function, and we will get the details of every form, like what is its action, what is its method, like get our post, and what are all the inputs fields that are present in that form. We will get all that all those things, and we will return all the details. After we get all these details, we will then submit this form. We will then submit this form with all those results, and then we will try to inject. This is the submit form function, and then here we will try to inject this our dummy JavaScript code that we got, that we have here in value. So in any input field of form that we have, we will try to inject this JavaScript code. And then over here, we do this post request or get request according to whatever we got in the form detail. And over here, we check that if that JavaScript content got inserted or not. If it got inserted, then we have to make it is vulnerable to true, because then the website will be accessible vulnerable. And then we will similarly we will do for all the forms, and then we will return this is vulnerable thing. So now, as all the output that we were getting was already being captured here, and and here data.toString function will convert all that data into string, and we will return back to this the client. Now I will show you the just a second. Now I will show you the demonstration of our extension. So first of all, we will run our server. So yeah, so our server is running. Yeah, so now our server is running, and let's check. Let's check. So here you can see, first of all, it's when it's fetching the details, it shows please wait checking, and it is a URL. And as we saw earlier, the website is non-accessible vulnerable, so that's what it shows. And here, as I told, that there are two forms. So in the output here, we can see this, that it detected those two forms. Now going to that website which was accessible vulnerable, if we now tap the extension, it's checking currently. Now here you can see the website was accessible vulnerable, and so here the output is displayed, and also the warning is given to the user. So now the user will be aware that this website is accessible vulnerable, and he will probably avoid entering anything sensitive in the input text field. So that is the entire demonstration of our project. Thank you.
Hence, concluding our project presentation, we have successfully created and implemented a browser extension that ensures security by popping up a warning message telling us whether the website is vulnerable to cross-site scripting attack or not. We have used the concept of detecting forms in the web pages, and we have used JavaScript inside the form to check the vulnerability of the web page. If the pop-up warning message is being popped up, the website is vulnerable to attack, and hence the user is advised not to use that web page or enter any other confidential data or credentials in that web page to prevent the loss of data. Coming to future enhancements, since our model have used the forms in the website and then it checks the vulnerability to XSS attacks, we are looking forward to implement the model without using the form, also to prevent the loss of sensitive data and personal information. This model is not using any kind of machine learning algorithm or deep learning concepts, so we are further looking forward to include those algorithms so as to find the accuracy of the model. Furthermore, the code needs to be updated frequently so that it goes hand in hand with the technology and beats any other techniques used by the hackers to steal the information. Here we have mentioned the references we have referred to during the research work, implementation, and creation of our project. Hence, thank you.